right, so now we're learning another type of factoring. So far we have the common factor, which we always look for. Then we have three-term factoring, which is the complex and the simple trinomial factoring. And then two-term factoring when we had the difference of perfect squares. Now we'll notice here we have four terms. So this type of factoring that we're going to do is called factoring by grouping. That's a bad U. Okay. Factoring by grouping. So what we're going to do here is we are going to group our expression. First of all, we look for the common factor, and there's none common to all of four of the terms. So we're going to group, and when I group, I'm just going to put little lines underneath my little groups. So I can say, okay, that's a group of two, and that's a group of two. And I'm going to common factor within the groups. Common factor within the little groups that I made there. Okay, so when I look here, when I just use these two together, I have a common factor, and I got to put my equal sign there. X squared will divide into both of those and give me x plus 1. And then I go to the second group. Now in the second group, you'll say, well, there's nothing in common. Well, for the grouping method to work, you have to do both groups. So if there's nothing in common, we're going to factor out a 1, because one will always divide. It really doesn't change anything, but we have to take it out. So we're going to take out a 1, and we always have to factor out this sign. So if this had been in minus here, we would have to take out a -1, but here it's a plus, so it's a plus 1. When we divide x by plus 1, we get x, and we divide plus 1 by plus 1, we get plus 1. Now it almost looks factored, so this is what you want to be careful about, because it's not factored, because see that plus 1 plus sign right there? It's not in a bracket, it's not multiplied, it's added. So we're not done. But instead of having 1, 2, 3, 4 terms, now we have one big term and a second big term. So what I got to look for now is, I'm going to common factor again. Common factor again. All right, so I'm going to look at both of them, and I notice, they both have an x plus 1. So I'm going to factor out x plus 1 from both of those brackets. So it means I'm going to divide this whole bracket by x plus 1. And what's going to be left when I divide all of this by x plus 1 is just going to be x squared. And I divide all of this by x plus 1. The only thing that's going to be left is the plus 1. So now I've taken the x plus 1 out of both of those and left with this. And look, now it's factored. Okay, so grouping, you try to group it into two groups where they have common factors in each of those groups. So for example, in the second one, I have ax and ay. Those look like they have things in common, and the b's also. So I'm going to group them into two groups, and I'm going to put an equal sign here, and I'm going to common factor within the group. So I'm going to take out the a. Now here in the second group, I want to take out a 2 and a b. They both have a 2 and a b. But remember, I have to factor out that sign right there, that minus. So it's going to be a negative 2b. And when I factor out the negative 2b, I'm dividing this whole thing by negative 2b. The only thing left when negative divided by negative is a positive. And then the only thing left there is x. That will be a positive and a y. Now hopefully, now I've got two larger terms. Is there anything common to both? Yes, they are. They both have an x plus y. So I can take, now I'm just factoring out the common factor in those two, x plus y. And when I factor it out, I divide it out of this one, I'm left with a. And when I divide it out of this one, I'm left with minus 2b. And there it is, all factored. Now, we'll do this again. Now when I look at this one, I say, okay, I'm going to divide. So they both have an x here. But when I look at the second one, I'm going, I don't see anything really in common there. I think I'm going to switch the order around, because if I put the x squared with the x cubed and the 4x with the 4, then they both have common factors, both of the groups. So I'm just going to my first step, I'm just going to rearrange so that the groups are a little more balanced in terms of each having their own common factors. So I'm going to put them like this. All I've done is change the order. I haven't changed any of the signs. And then I'm going to group them together into two groups of 2. And now I can take out a common factor. The biggest one I could take out would be x squared, which is kind of nice, leaving me with x to the 1 plus x squared divided by x squared is 1. I have to keep the 1 because otherwise it would be disappeared there. When I'd multiply it out, I wouldn't have anything to make the x squared with. Always factor out that sign there, negative 4. So now when I divide negative 4 by negative 4, I get 1. X doesn't change. Negative 4 divided by negative 4 is a positive 1. We're not done yet because this is not factored. Although there are brackets, still not factored because of that minus sign. We have to say, okay, now I have two big terms. Is there something common to both? And I see indeed there is an x plus 1. And then I'm going to factor it out of both. So I'm dividing both of these by x plus 1. And I get x squared minus 4. Wow, I'm factored. But the question is, am I factored fully? Because yes, it's factored. There's nothing outside of the brackets. But you're always kind of on the lookout. When your brackets have more than just an x, if they have a square in them, you should say, maybe I could factor that again. Does that look anyways familiar? It should. Because that is a difference of two perfect squares. Aha! So I could actually factor this bracket again. This one's going to stay the same. But this one, remember our conjugate friends? X, 2, 2, 1 gets a plus, 1 gets a minus.